Thank you so much. I think the topic is quite broad, and we have a lot of different subjects to cover. So we'll dive right into it. Just logistically, we'd like to take questions from the audience as well, so you can think through some of the questions. We'll have a roving mic going through it. So I'll just open it up in a little bit time. If you have questions, just raise your hands, and we'll take questions from you. So what I thought is, since we just have 40 minutes, and the topic is so broad, we'll just dive right into it. First and foremost, I think question for you, Mark, is when we talk about high-performance computing, at least in my mind, how is it different, for example, when I think about cloud computing, hyperscalers? How do I think about high-performance computing from that aspect? And yeah.
Sure. I mean, broadly, high-performance computing is the ability to highly parallelize GPUs and/or CPUs together to create mass performance. Okay. So it's creating systems that are, the most powerful, the fastest in the world. Mm-hmm. The majority of those systems are processing AI type applications. HPE has an amazing history in this space. We currently have implemented 7 of the largest 10 global fastest supercomputers. The top 3 are exascale systems. That means they can compute, more than 1 billion computations a second. In Europe, we've implemented the fastest 3 supercomputers, and ultimately, as we all know, data information creates AI outcomes and high performance compute outcomes. And the faster you can create those outcomes, the more powerful the supercomputers you can build, the faster and the greater outcome you can create in this kind of context. So hopefully that answers your question.
It does, and I think the kind of leads to the next question, which I can pose to Lene, is around the applications. I know we've heard some of the applications mentioned, but when we spoke, you talked about some really interesting real-world applications where already this is being used. So if you can kind of elaborate on that and just explain.
Yeah. So from the point of view of the Novo Nordisk Foundation, we work to enable access to such high-performance computing. And so our interests are quite broad, as nicely explained by Nadia a second ago. And we would like to serve both academia and industry. Mm-hmm. And looking in the European landscape, the EuroHPC machines basically served only academia. Okay. And we also had the challenge that they were actually quite cumbersome to access, very lengthy procedures for accessing the machines. So it was really important for us that it should be, first of all, available and should be of the highest quality and should be easy access. Mm-hmm. That was like the top priorities from the stakeholders who we interviewed about their wishes for such compute modalities. And then Nadia already mentioned a number of really exciting use cases which are ongoing, really, providing excellent results. In addition to these, I'd also like to mention another priority of ours, which is really within the health space. Mm-hmm. So the Nordic countries have, I would say, a goldmine of health data, which is really well protected, and it should continue to be so. But if we make smart use of that data, we can really accelerate the health and also understanding the mechanisms that lead to health disorders of various kinds. So we'd actually like to unlock the potential of this data. And that's difficult because there has to be access to totally secure compute, and the compute has to be actually on Danish soil, as Tifjan is, or in the Nordics or in the Europe, somewhere where we really trust that we have control over the data and over the compute. And also, of course, we need to make access to the data in a responsible manner. So this is another very high priority for us.
Got it. I guess the next question immediately is around AI, and I'm looking at you, Andy, with NVIDIA being kind of the gold dust that is kind of enabling a lot of this. How has AI changed it? Has it kind of accelerated it? Has it changed the trajectory when it comes to high performance or supercomputing? What has it done to the workloads?
Yeah, absolutely. It's changed everything in the last few years. And from the machine architectures, but also the software architecture and applications. But let's start with the applications. So, there are multiple ways that AI is impacting supercomputing applications. The first is, people are taking their computational kernels and swapping them out with AI data implementations instead. Now, the effects of that, you're basically replacing the equations with language models that are driven by data. The effect of that is typically, the models can become a lot more accurate, but a lot quicker to run and a lot more energy efficient. So this is three dramatic impacts because you're reducing time. And Nadia mentioned weather forecasting as an example. So the first implementations of AI and weather forecasting started to appear around 2019, and then there's been this massive explosion of AI models in weather to the point now where ECMWF, which is the European Medium Range Weather Centre, which is kind of the gold standard in this, their AIFS model is now consistently higher performance, or delivers better quality forecasts than their traditional numerical weather prediction method, and that's something like 300 times the accuracy, and I don't know how many X% more energy efficiently. So at the applications level, basically that technique that they've used, you could apply across many other areas, whether it's materials science, chemistry, etc. So that's one thing. At the machine architecture level, then HPC is always about keeping things in balance. You're constantly adjusting where the bottlenecks are and trying to minimize the bottlenecks. So typically in AI systems for growing large language models, probably 60% of the time is spent in communication rather than actually in the compute part. So if you don't have a strong interconnect, then it's akin to having the best office blocks in the city centre, but no transport network to get people in, something like that. So you have to constantly look at the balance and use AI to help you with that. And then the data centre design, it's absolutely having an impact there. So, as we scale up system size, the node sizes to bring in more data and minimize communication between nodes, that's meaning the rack sizes are getting bigger, the power density is getting bigger, which means we're having to change data center designs to use direct liquid cooling, and our partners, HP, for example, are doing exactly that. And that makes the whole energy equation much more efficient than it has been in the past. So dramatic increases in energy efficiency as well.
Got it. And finally, I think to Per, I think the question around quantum computing and its role in supercomputing as well. There's just a lot of excitement around quantum computing, particularly in the last year. There have been just so many announcements where it feels like it's kind of getting into mainstream. So how does that fit into the supercomputing?
Yeah, so I guess, obviously quantum is one of these generational technologies. There's really nothing else on the horizon that's of, that potential. And so I guess there's a couple of aspects of this. One is that it's kind of a strategic necessity to supercomputing. If you really do want to disrupt energy consumption, for example, it's literally the only way, right? If you really want to change those energy curves. I think there's a lot of areas in AI as well that are, low data regimes, for example, where again, it's, you need alternative ways where it's a kind of, again, a strategic necessity. But there's also the strategic opportunity, where it's, the combining AI and quantum, you get a compounding effect, right? And I think that's what people are really excited about, is if you really put these two generational technologies together and really impact science and engineering in ways you've never seen before. And even though quantum is in a sort of an early stage, we're already seeing some of these benefits. We've worked with companies like BP, for example, and DTU here, where we're already seeing in these models, generative AI models, molecules that they've never seen before, right, by adding quantum. So this is, again, early, but really exciting opportunities here to do something that is completely different and beyond pure classical.
Got it.
And so just finally, just the way to look at it, though, is that quantum is yet another accelerator, right? These AI supercomputers that's what they are. They're just composed of converging technologies, different types of technologies, be they, compute or storage or networking. And that's really how to think about quantum as just, another tool in that converged AI supercomputer.
Got it. So I have a lot of jumping off points here, energy, use cases, all these things. But I think the biggest question right now is around sovereigns and governments and their use of supercomputers. We were just joking that it's no longer enough to make $1 billion announcements. Countries are making $100 billion. I saw a figure even recently around $1 trillion in the trip to the Middle East, right, when Trump visited there. So we are talking about massive numbers here. I'm just interested in the panel's view, each of you. What is the role of government in this in terms of what is the right model here to engage? Because obviously the costs that we're talking about are not trivial. These are massive. What are the different models and how should governments even approach this, particularly when the end use case is being driven by the industry, but then there's a huge upfront investment also needed? Maybe we can start out with Mark and then we can...
Yeah, sure. I mean, clearly it's critical for government to find the policy and the regulation, not to over-regulate, but to control the use of this data is critical. Sovereignty and data security are absolutely critical. That's why we're seeing sovereign governments across Western Europe build their own AI supercomputers, their own AI factories, in essence to enable at a sovereign government level governments to create more outcome from the huge amounts of data that resides within a state. I think sovereignty though also goes out to the enterprise. I mean, we're seeing enterprises build their AI supercomputers, their AI factories again. When you think about the intellectual property and the value of data inside corporations, it's a similar notion. The need to protect data that creates the outcomes for an enterprise is similar to that of government. But I mean, the opportunity to create outcomes that improve the lives of citizens, I think, is just incredible in so many different verticals. Healthcare being a great example, weather being another. The efficiency of government. I think these whole aspects are going to change the way we live and work. And I think the role of the state is to create the framework to make that work within their societies.
Makes sense. Leonard, the question I had for you, particularly on this topic, is Novo has a pretty unique approach, and particularly I think in Denmark also that we've been in terms of this partnership between public, private. So if you could speak about that.
Yeah. So I think as also Dieter Bjerregaard said in the opening speech, in Denmark we have a tradition of performing public-private partnerships.
Okay.
So we actually work quite closely across different sectors of the society, and has worked really well for us, for instance, during the pandemic, and also in the establishment of GPhiOn, the supercomputer. And so basically of course, the different entities have different interests, but we do come together and we quite easily, I would say, actually align on what the purpose is here. And so I think, in my opinion, the role of the government is basically to safeguard the population and also to give the population the right opportunities. Mm-hmm. So, of course, you cannot just over-regulate, because that wouldn't give your population, your companies, the right opportunities. So you need to find the right balance. And I think actually another really important role of the government, at least in Europe, is to safeguard democracy. Mm-hmm. And so by that, I mean, for instance, we need access to language models which reflect democratic values, which reflect the ethics that are prevalent here. And it's quite clear, I mean, there's so many examples of the large language models out there that actually express an opinion. And so we just have to be really much aware that this is what they do. And, our children, they use these models, so they get these under the skin. And that's why this is a role of the government to ensure that what the children use, whatever the entire population use, they does express the democratic values that we stand for in Europe.
Got it.
And I think for that, actually, the whole supercompute area is extremely important.
Got it.
Yeah.
Andy, your thoughts on this?
I think those points are really valid. I was just thinking when you were speaking then that if you take the area of health, then health priorities for Denmark are going to be different to health priorities of England or India or Japan. So having that local data to create LLMs that are relevant for the local population, whether it's protecting languages, protecting legal structures in individual countries or regions, or health data, that's critical, I think. So that's why, you may have heard Jensen Huang, our CEO, saying, sovereign AI is critical for every country. It's going to be, part of national critical infrastructure. And wherever the technology comes from, creating those sovereign environments around that's protected within national boundaries, I think, is critically important.
But the question I had for you on kind of the similar topic is around quantum. You mentioned it's a transformational technology. How important would it be for, again, when we're talking about AI, for governments or countries to have their own version of quantum? Is this something, because again, the investment in quantum is not trivial. How do you think about this in terms of access to this technology across countries?
Yeah, it's hard to be in quantum and not think about that sort of a question. I mean, there's obviously a lot of investment in quantum, both private and public. Just like in supercomputing, it's of strategic national interest. So you have both kind of national and regional interests. And so even now, we're starting to see the importance of government frameworks to both protect and facilitate the technology, right? On the facilitation side, we look at our global supply chains. I mean, we have partners here, multiple partners here in Denmark, for example. The UK and Denmark has a quantum bilateral agreement, right? There are other agreements, for example, which are more intended to almost protect technology, like AUKUS, the military alliance between the US, Australia, and the UK. So navigating all of these things is non-trivial, but it's certainly essential that you don't stunt the growth of the industry, right? That you are able to kind of keep that focus on building these international supply chains, which are essential for the technology to become a reality in the first place. I mean, I arrived from Tokyo last night, and a similar story there. There's agreements from the UK and Japan, and there was an opening of a center in Japan. NVIDIA was there. So you see the same sort of players around the world, but that facilitation is absolutely critical.
Got it. I can keep talking, but I think at this point, questions from the audience would be welcome. If you have any questions, if you can raise your hand and we'll get a mic over to you. Are there any questions? Yeah. Yeah, quite a few questions. So yeah, please do. Just a reminder, introduce yourself and then keep the questions very brief. That way we can get through as many of them as possible. Please.
Yes, my name is Shabab. I'm working at Rockwell Group as a manager in data and AI. And yeah, we do a lot of work with generative AI in general. But my question is more regarding this point about, you guys discussed governments, in light of ensuring democratic principles and stuff like this, make their own models. But even if a country like Denmark or any country makes their own models, that does not stop other companies making their models in an open source way, and then it is accessible by everybody. So just because we make a model in Denmark doesn't mean people actually use it. I know that there are some LLMs that have already been made in Denmark, in Norway, and Sweden as well. But of course, the performance is subpar, and it will always be, because we will not be as good as the US or China. We saw what happened when DeepSeek came out, for example. So in that sense, is it actually possible? So is it just if we have the compute and
Okay.
yeah, does that solve it?
So I guess the question, yeah, it's more around, we talked about the hardware stack, the software is just as important. If you cannot compete on software, how does it work? So maybe Lene, you can start, and then Mark, I think you had a point in you as well. Yeah.
So in my personal opinion, I think we would need to go on a European scale to have something that could actually compete with, say, what's being developed in China or by Elon Musk. But I think we can actually do it on a European scale. But I think we definitely need to go larger than Denmark. That would be my answer. And, if the schools across Europe, they say, okay, this to the children, this is what you should use, to do your homework assignments, it would have an impact.
Got it.
Even if they have access to everything in their free time.
And my point of view on it, that there are going to be thousands, there already are thousands of large language models. So protecting or securitizing the large language model layer, I think, is probably not feasible. Ultimately, it's about the application layer, and it's about the data that is used to build the models and create the inference. And that's where security becomes absolutely critical, because you have to be able to secure data that is sovereign at a state level or at a company level, because that's your intellectual property, that's your crown jewels. And I think that's a focus point that governments and enterprises need to really think about, how to protect the data that is sovereign to them, that has the value and that creates the outcome, and then to create the application layers efficiently to release that data to create the difference in society in a government or an enterprise context.
Got it. Right. There's a question there. Yeah.
Yeah, a slightly different question, more focused on compute. There's a lot of focus on centralized compute here, and with the emergence of quantum computing, I can see that trend. But I also see there's an opportunity with distributed compute for resilience purposes, but also because it's bound by users, devices in a country. Is there any thoughts or any opinions on how distributed AI compute using your devices when spot price is practically zero, when the sun is shining, that this could be a complement and provide some resilience and security for keeping our data within boundaries?
Maybe Andy, you can maybe start and then we can. Yeah.
Yeah, I think there you have to distinguish between training requirements and inference requirements. Training requirements are going to need those much bigger machines, but and centralized typically. Inferencing could be much more distributed. So yes, in answer to your question, I think you could have that distributed framework, but you'd still need some large centralized facilities to do that. Big training using centralized data. And the other thing, you don't want to be moving data around too much because that's energy inefficient as well, and leads to other security issues as on protecting data.
Oh, you had a point.
Yeah, so it's a great question. I mean, this has been a bit of a trend for a while now, but we have a lot of people approach us about the interest in edge computing, which is larger than one might consider as edge. I mean, so basically it's being stretched, if you will, the kind of compute capabilities. And there's a lot of these large instruments like the square kilometer array, a digital oil field, for example, where there's interest in doing as much local compute, to Andy's point, right, before you start moving the data. So I think there's absolutely opportunities there to implement much more capable computing on the edge, which is more near data, if you will, and then send back towards could be multiple layers even of centralized compute.
Got it. I had there's a question right there. I think. Okay. While you're getting there, I'll kind of ask my question, which is, I think there's a question around the software and the models, right? So far, we've talked a lot about the hardware, the stack, the kind of chips. Equally important, it would seem, are the software that's needed to run with it, whether it's CUDA, whether it's the open source models, the large language models. I'm just interested in kind of the panel's view on how do you think about software competency as well, because it's one thing to build up and stand up these supercomputers. It's another thing to actually derive the applications from that. And like we mentioned, whether you use an open source model, whether you have your own proprietary model, that to me seems to be just as much of a differentiator as the hardware itself. So maybe you can just have kind of your quick thoughts on starting with you, Mark, in terms of...
Yeah, sure. I mean, I'm sure Andy will talk about CUDA and that aspect of it. One of the things that I'll say from an HPE perspective, we've seen is the ability to improve the performance of the application is really significant. So having the expertise to understand how applications relate to technology and to create faster and more performant systems is very valuable, not only because that creates faster outcomes, but it also reduces significantly the cost to compute, the cost to get to that outcome. And when you think about a lot of these supercomputers, the capital cost of them, you can increase the performance of the applications that run through them by 15 or 20%. If you have a $200 million capital investment, that's a very significant additional outcome of science or additional return on investment. So maximizing the ways to improve the performance of the applications is critical. But I think you guys may have slightly different nuanced answers.
Yeah, and just when, Lene, the one question I was interested in your view, you've been pretty vocal in the fact that kind of having your own software stack is just as important, building your own models, and being able to kind of push those, or at least, so what is kind of, how much investment in that is needed versus kind of what you're doing on the hardware side as well?
So I think from the foundation-wide side, we're very much focused on training the working force. Okay. So the people who would be able to make these algorithms or understand the algorithms that come from NVIDIA, for instance, which they also use, but they need a certain level before they can do that. So we put a lot of effort into actually university training of, say, young people who go through their career, but also vocational training. So those who say are already experts in a certain field, and they may be in academia, but they may also be in industry. So they basically need more training before they can really go and access GFION, for instance. And my advice often to those who come, say, from a smaller university somewhere in Denmark, and they say, oh, how do we get started on this? I actually advise them to get a smaller local cluster so they can learn how to use the models to do simple things before they get access to GFION, because Nadia would go crazy if all these people immediately approached you and wanted to start from scratch on GFION. You can't, you need some basic knowledge before you can do the scaling. And that, I think, as a foundation, this is where we see a lag, actually, of experience across the ecosystem, actually, both in academia and in industry. So we need to build that expertise before they can actually do this.
We need to have a conversation about university training then.
Yes.
So one of the things we do, we have this thing called the Deep Learning Institute, which is our main kind of training facility, both for industry and in academia. And for academics, typically those training courses are free. And, we also do train ambassadors. So if somebody's an early career academic has gone through that training, they can be certified and then go on and deliver that training. So there's a multiplier effect. But those training materials are also available as self-paced training. So anybody can go and do those training courses. And once they've registered, they will get access to cloud credits to run those training courses. So you don't necessarily need to have access to GEFION to do that training initially. You can get yourself up to the right skill level and then apply. So that's one thing. Just coming back to software and the whole software ecosystem and where to innovate in that software stack. NVIDIA puts probably far more effort into developing software than it does in developing the hardware. But our whole point is to create a platform and allow people to take whatever point of that platform they want. So some customers will say, bare metal, that's all I need. I'm going to use my software stack. I know exactly what I want to do and just apply it to that. Others are going to take higher levels of the software stack up to, the CUDA layer being there's hundreds of libraries for different application areas available, and then applications that's sitting on top of those. And what we're trying to do is make it as easy as possible for people to use that software. So we'll create templates and blueprints for people to download and adapt to their own use cases. So if you want to develop a chatbot, for example, there are example chatbots that you can download and then adjust to use your own local data. That being a good case in point. So yeah, we're not. And one of the other things as well is if you do use the NVIDIA software stack, you're always going to be guaranteed it's optimized for the latest generations of hardware. So if we take GEFION, for example, the software that was available a year ago for the H100, during that time has been optimized significantly. So today, that same software running on that same hardware will probably run 20-30% faster than it did a year ago because there's constant adaptation there. So our message is, if you're a scientist wanting to do science, not necessarily develop the software stack or all the tools to do that. You focus on your bit of the problem and let others do their bit. But we're not dictating. We're saying you can take it at whatever level you want and integrate at whatever level.
Makes sense.
Does that make sense?
But question for you specifically on the quantum side, how does the software stack differ, or how different is it for somebody to be able to adapt to that?
Yeah, so all of that, Python or CUDA, with a call to quantum. It's simple.
Okay.
Like the back end in CUDA quantum is the photonic back end is us, right? And but more importantly, our entire focus is around adoption. I think it was on one of Nadia's slides about lowering the barrier to adoption, right? If any technology is challenging to use, people won't use it. They just won't. That's human nature, right? It's been like that in high-performance computing forever. So our philosophy is just make it as easy as possible, right? So you program the machine in PyTorch or Python. And you can't as soon as someone has to rewrite a model just to take advantage of some new technology, you're sort of dead in the water, right?
Sorry, I kept you waiting for your question.
Okay.
Yeah.
Can you hear me? Lenny, you briefly touched on it, as did Andy. I don't hear the state of Oregon worried about data sovereignty over California, nor Fujian province being worried about data being stored in Sichuan. Lenny, you just said it. Mario Draghi is criticizing Europe's competitiveness due to a lack of a single market for digital services at scale. And yet we still seem to be obsessed with the idea of sovereignty at the European nation state level. I mean, this needs to stop. I mean, you have a GDP as big as the US and a population larger, and you have a huge brain power at the human level. This scaling of a digital single market has to happen. Why do we not trust in the European digital single market?
It's a pretty big question, but I think it's a pretty important question as well, which is, yeah.
Well,
I don't think you're the representative for all of EU, certainly not, but yeah.
Okay.
I think it does matter in terms of EU competitiveness, which is one of the themes.
I'll be happy to give it a shot. So with GFION, I would say, but I guess it's up to you to answer that question also, Nadia. We start in Denmark, but we are thinking much larger. I will not reveal all details at this point, but we definitely also think European. And so if you look back, I mean, even at the situation today, it's the European Union is in many ways a fragmented market. Mario Draghi is completely right. And this is something we need to solve, because if we would be able to create one unified market, and we would be able to give, say, the European industry and also the global industry access to that market on easy terms, that would be such a benefit. So it's something that we need to work towards. And I think maybe within compute could be, one of the first places that we actually do that. I mean, maybe you read about the gigafactories which are on their way. That is one, step in the right direction. I think within quantum, we may also be going there. I hope we will also be going there within the life sciences, the pharma industry, something we're working really hard on from the Novo Group side. So we're definitely working really hard to achieve what you're saying there. But it is difficult because so far everything has just been divided by 27, right? So it's hard. Yeah.
I think, initiatives like EuroHPC have been fantastic in providing large-scale facilities to help people get going and training. And, and we've seen some large companies and startups being created from use of those facilities across Europe, so helping grow European GDP. And if those facilities are properly federated to provide access to the different machines, then when the EU AI factories and eventually the gigafactories come on stream, we will have a very well-balanced hierarchy of structure across Europe, and I'm including I'm from the UK, so I'm including UK in the broader definition here as well.
I also include UK.
Good. Thank you.
We just have 5 minutes left, so maybe time for one or two quick questions. Yeah, sorry.
My name is Stefan, and I have a question on the sovereignty again. Yep. So we talk a lot about sovereignty of data and having data center in Europe or in the countries. But I also would like to point out the sovereignty of technology, because I see, let's say, a strong dependency on NVIDIA technology right now. So NVIDIA is dominating the hardware market and make it easy to consume the software stack. I think there is a little bit of danger, I would say, because, how can we have something a little bit more of freedom of choice with the same quality of software stack and hardware and so on and so forth? So what is your opinion on that?
Yes, I guess the question around vendor lock-in or kind of being tied to a particular, yeah.
I mean, my perspective on that is right now the customer goes where they believe they can get the best outcome, right? And the market share statistics bear what they're choosing out. I mean, we don't favour one GPU provider over another, by the way, as HPE. One of our values is to help our customers define what the best GPU is for the outcomes that they're looking for. So, for example, I mean, a large proportion of our implementations around Europe, both in a public sector and enterprise context, are with NVIDIA. But a couple of systems that we've recently implemented are with AMD. So, ENI is a great example of that. It's Europe's fastest supercomputer today. used for huge range of applications in the oil industry in Italy with the NI. That's built on AMD. The Lumi system in Finland, which is an EU system, was the largest system in Europe. That was built on AMD. So it isn't only NVIDIA, but I mean, let's be clear. I think the market statistics are like 95.5 at the moment, and that's because they're providing what customers need. And that may change over time. Who knows?
Andy?
Well, yeah, I agree with what Mark says clearly, but I think that there's no vendor lock-in there, first of all, because as I mentioned, you could take whichever level of the stack and develop around that. So, and also, there are big initiatives in Europe for developing new microprocessors, new interconnects, etc. Whether Europe is doing it at sufficient scale to have an impact, that I think is the question, because, if we look at, say, what's happening in Taiwan and new investment in large fab plants there, billions being spent to generate those next generation chips. Is Europe serious about investing the money needed to do it? That, I think, is the question. But from today's customers, they're going to go, where they can go to get the best, performance per dollar.
Got it. We have time for one more question. I think we're just, 3 minutes left, so probably this will be our last question.
Thank you very much, Michael from Germany. Question to Andy and to you about the fragmentation and the European approach. I doubt that this works because I just spoke 2 days ago to the head of Deutsche Telekom, and he explained me that they have the problem that they pull everything together because after 20 or 30 kilometers with a backup, I mean, you can't run the databases anymore. I mean, and you always need a backup. I mean, how do you do federated stuff and with a big supercomputer with all the latency and all this stuff? I mean, just a technical question, because I'm a little bit surprised how you want to square this question.
Well, I don't think there's any one answer to that question. It very much depends on the application and the workload. You'll see the latest systems are increasing the node sizes with the amount of memory and making sure that the GPUs and the CPUs are very closely coupled together to minimize, or to maximize the bandwidth in between the different components, so you can increase the performance dramatically. That's all around centralizing in a scale-up facility to maximize performance in a smaller footprint as possible, and then you have the scale out if you want to, extend that further out for multiple large nodes. We're going to see over the next few years those systems becoming even more dense as they grow, and that has implications, as I mentioned, for the data center industry. In financial services and in other heavily regulated industries, you're always going to have the need to have resiliency in your system somewhere. Other industries may not have that same need to the same extent. So I don't think there's any one answer to that question.
Got it. Are there any more questions? I think one. Sorry, Lenny, you wanted to add something?
Yeah, actually, I wanted to add something to your question, because I think in Europe, because we've been so fragmented, we've had difficulties in having, large enough bets on advancing a certain technology in order to be competitive. It's quite clear that Europe is falling behind because of our lack of innovation and scale in deep tech. And I think the fragmentation of the market is really the main reason. But I think if we could change this around, that would make a huge difference. And I think within microchips, it might be too late in a way, because then we would always play the game of catching up. However, there could be new technologies, say quantum, where we so far are actually among the leaders in certain aspects of quantum. If we could maintain that leadership and, strengthen it, I think we could have a chance of becoming leading there. And that, of course, may have a spillover effect to the next generation of quantum chips or chips in general, right? So that I think that's actually the way to go. Instead of, constantly trying to catch up, and try to be there and do it, seriously with large enough investments behind.
All right. I think we're out of time. We still have a lot more things, but I'm sure the panelists will be available. Thank you so much for your time. It's quite interesting. Thank you. Pleasure.
Thank you.